All right, so here we are, ready for more IntelliJ goodness.
My slideshow's not working.
You are going to write, so we already did the countdown. Okay, so here's your instructions. You're going to write a method called up to n. This method will contain a for loop which counts from 0 to n, where n is assigned when the method is called. That should be a hint to you what n is. Try this thing. All right, let's look at this. We can't spend too much time on it because we have even harder ones coming up. However, I am big brain, so all of these build on each other, which means write them down and pay attention. So I'm seeing a lot of struggling, which means I'm going to have to crack down a bit. Pay attention. What this should look like is private void count to n. Or up to n, sorry. That's fine too. Now, because I said that n is assigned when the method is called, it must be a parameter, because that's the only kind of thing that gets assigned as the method gets called. So int n. There's our method. Now, because it's a parameter, if I was in main, and you don't have to do this part, if I'm in main and I say x dot up to n, I have to pass in a value to use for n. So effectively, if I call up to n and pass in 10, what I really should be doing is counting up to 10. So this allows more flexibility in our loop. So instead of just counting up to a fixed number, we're now able to count up to any number that gets passed into us. Here's our for loop. For int I equals 0. You could have used something other than I, but you could not have used n. As long as I is less than or equal to what? Not 10, n. As long as it's less than or equal to whatever n is, we want to keep going. And then I plus plus. What happened? There we go.
Wait, how do you make all the numbers above counting? There's a red square where the...
Oh, if you infinite looped, yeah, you have to hit the stop button and up there. We're printing out I. Which of you is confused on what happened? None of you? Really?
No, that was pretty easy.
Even those of you who didn't even get close? You get it? Okay. Because we're starting to seriously combine some knowledge. Let's do another one. We're doing several today. All right. This one is going to be called, make a method called print all odd. This method uses a for loop to print all the odd numbers between 0 and 100. And a lot of you are like, but how? First off, what is the definition of an even number?
Even.
It's a number that's divisible by 2.
A number that is divisible by 2. What does divisible mean?
It's a big word. Divisible. You can split it into multiple.
All right, here's the definition of divisible. We're going to dive back into elementary school for a second.
Great.
Divisible means it divides clean with no remainder. Okay, so for something to be even, well, actually divisible technically just means it can be divided. Evenly divisible, in other words, even means you can divide it by 2 and have, or evenly divisible means no remainder, and even means divisible by 2 with no remainder. So how do I tell if something is divisible, or if how do I tell if something is even in code using division? Sort of. So I need to get so when I perform the division, I need the remainder. How do I get the remainder of a division problem? We covered this briefly. Like, really briefly.
With the fraction.
Well, so here's the thing. When I perform division on an int in Java, it will not give me the remainder. It will just round it. So there is a specific operator that will tell me what the remainder is. It's called the modulus operator. The modulus operator, which is the percent sign, yields the remainder of a division operation instead of the answer. That should be all you need to know. So in this one, you're only going to print out I if I is odd. Note the emphasis on the word if. All right, let's do this. Code time. I don't want to run out. So, who would like to volunteer the method part? Not the for loop part, but just the method part. Okay, go ahead. Right. Shish, shish, shish. Private or public, yep. Curly braces, curly brackets, whatever you want to call them. Okay. Squiggly brackets, something. All right. Who would like to give me the for loop? Who would like to give me the loop itself? All right, Clayton, go ahead.
Or
that is correct. And how about the if statement, a third person? All right, let's go.
If parentheses I, whatever the symbol is.
Mod.
Yes. 2 double equals 1. Curly brace.
All right, now for those of you who might be confused on what just happened there. So, the modulus operator yields the remainder instead of doing normal division. So, if a number's even, that means when you divide it by 2, there shouldn't be a remainder. If there is a remainder when you divide something by 2, it'll always be 1. So, if I do I mod 2 and the remainder equals 1, this must be an odd number. Mostly just because it wasn't 0, even though all odd numbers will have 1 as the remainder. I could have also written this like this, and that would be acceptable. This says, if I do I divided by 2 and the remainder does not equal 0, it must be an odd number, therefore print out I. That makes sense, yeah? So there's our print all odd. Notice there are no parameters, because in the description for this practice problem, I'm not counting up to n or anything else. I'm just counting from 0 to 100. We have a very fixed number. Now, let's combine our knowledge. I'm going to go ahead and minimize this. Let's combine this knowledge for the past 2 things you've done. Make a method called SumOddN. Wonder if any of you can see where we're going with this. Okay. This method will, one more, calculate the sum of all odd numbers between 0 and n. N will be assigned, or well, not capital N. N will be assigned when the method is called. You shouldn't even need that hint. So this is cumulative, and by cumulative I mean it will use principles from the previous couple of problems and it adds a new concept in. Not a concept you haven't learned, but one we haven't used in our loops yet. Give it a shot. Break this down into little problems. Start with the stuff that you know exactly how to do, like writing a method, giving the method a parameter. Yes. Or sorry, giving the method a parameter, writing a for loop that counts up to n, checking to see whether a number is odd or not. These are all things you literally just did in the last half hour, so you know how to do them. No, it would not be a parameter. No. So, observe. Now, you could make it work with a parameter because a parameter is fairly simple, fairly similar to what you're actually going to do. But let me write this one out for you. So it'll be a private void called sum odd n. That should have been pretty easy. Most of you should have gotten that far. However, n will be assigned when the method is called. Please close Paint and Among Us and everything else. Pay attention to this so that you'll learn. Yes. So, this is creating the method. This part should be a piece of cake. You should be able to write a method in like 10 seconds. If you can't, you need to spend some time this weekend writing them down on like a piece of paper or something. Screenshot your code like this, just like screenshot this and do variations on this over and over again until you got it memorized. Now, in the parentheses, I said that n will be assigned when the method is called. Now, the only way that something can be assigned when the method is called is if it's a parameter. So, int n is a parameter. Now, some of you added a second parameter, and your line of thought was very close to right. You just missed a little thing. And you actually probably got it to work, because it would. But let's look at the for loop now. So for, and then it doesn't technically matter what you called it, but you want to get used to saying I for your first loop because that's typically what happens. So for int I equaling 0. And almost every time we make a for loop, it's going to start at 0. Almost every time. Not necessarily always. It depends on what we're trying to do. But the vast majority of the time, I will start at 0. Because we're starting at the 0th iteration. So it just makes sense that we would start because the loop hasn't even run yet, so we have 0 times run. Again, this can be different in here. We can write a lot of different conditions, but almost always it'll be like as long as I is less than or equal to something. In this case, how far up do we want to count? N. We want to count up to n. So as long as I is less than n, we keep going. And every time the loop runs, we increase I by 1, I++. And then we don't end with a semicolon, even though you'll notice it allows it, but what use is that? If we end it with a semicolon, the loop doesn't even do anything, it's just there. So I need to have braces so I can actually do something with the loop. Now inside the loop, because this is supposed to calculate the sum of all odd numbers between 0 and n, I want to see, just like in print all odd, if it's odd or not. So I'm going to do if I mod 2 is not equal to 0, and you could have also done I mod 2 double equals 1, and that's fine. Either of those works as long as you're finding out if it's odd. Now, this is basically where we were with print all odd. But our job is not to print out every odd number. Our job this time is to print out the sum. So we should only print once on this method. This method should only print out one number, and it shouldn't even print until the loop is over. So here's the end of the loop. I'm going to make some space here. This is where I should print. Some of you got very close, but you put your print in the wrong spot. This is where I'm going to print, right here. But what am I going to actually print out? I can't even print I because you'll notice here, outside of the for loop, I doesn't actually exist as far as the program is concerned. Once the for loop is over, I is deleted from memory. It doesn't keep track of it anymore. So we're not printing out I. Right. So I told some of you, or some of you may have figured out, that we need to create phone away, please, for the love of God. Take your ADD meds.
I lost my Adderall.
You're only hurting yourself. I really want you to do well. So, we do need to make a local variable. This harkens back right to the very beginning of when we started coding. Variables are for storing information or storing data. Methods are like for storing a bunch of code, which can include variables and loops and if and all that stuff. And methods kind of store that, but variables just store little pieces of information. And the best way to think of a variable, well, so first of all, a variable is not quite like in math. In math, when you have x equals something, x has a fixed value. We don't know what the value is, but it does have some fixed value. And in math class, you're always tasked with solving it. You got to find out what x is. In programming, we usually know what x is, or we know kind of what it should be. We might not know the exact value, but we know what kind of thing is in there. So what we want to store is, and what we want to print, is the sum, right? So we're going to make a local variable. We'll call it int sum. And we give it a default value of 0, because at the beginning of it, it's got nothing. So we set it equal to 0 by default. Now this is a local variable. A couple of you made it global, and that's okay, it would still work. But for this method, if I was going to be writing this as part of a bigger program, I would want to keep sum inside of the method that it's going to be used in. I don't want to have a bunch of global variables that only get used inside one method. If you have a global variable, it should be getting used inside of multiple methods. Does that make sense? So global variables can be used by multiple methods. Therefore, you should only make a global variable if it's going to be used in multiple methods. Because this sum variable is only getting used inside of sum odd n, I make it local like this, and I just create it in the method. Now I'm setting it equal to 0 because at the start, the sum is 0. We haven't added anything to it yet. And as a matter of fact, I can just go down here and say print line sum, because I know when I'm done, I want to print the sum out. The best way to think of a variable, I don't have a box. Crap.
You got a trash can?
I do have a trash can. You know what? I'll use the trash can. So variables are spaces in our computer's memory. If you took Exploring Computer Science with me, you should know all about RAM. Or you should know generally about RAM, random access memory. Memory is made up of billions of memory addresses. When we make a variable, we are storing, or we are naming one of those memory addresses something. So it's like, I swear I'm going to get a box specifically for this demonstration one day.
Something off of Amazon.
I have plenty of boxes too. So when I say, I'm going to use the trash can as the example because I don't care. So when I say int sum equals 0, let's pretend this is some unnamed memory address. When I say int sum equals 0, the computer is going to find an unused memory address and name it sum. That is useful to us programmers because up until that point, the memory address has some really long, complicated name, and there's no way we could remember it, and coding would be like really difficult / impossible. However, because the computer names it sum, now anytime we want to refer to this specific memory address and not that one over there, is because I know this one's name is sum, and so I can refer to it as such. Now, the important thing to remember is that a variable is not the data inside of it. The variable is the space. And then I happen to have a can in here, so I'll use that. That's still sum. I'm not going to pick that up. So when I say sum equals 0, I put the number 0 inside of sum. Therefore, anytime in my program where I check the value of sum, it's going to tell me it's 0. However, I am allowed to do basically anything I want with this space as long as I use its name. So I can say sum equals 10, and that would basically throw out the 0 and throw a 10 back inside of it, so that anytime after that, I'd be talking about a 10. That's not what I want to do here, though. What I want to do here is take whatever was in it, add something to it, and then put it back. Does that make sense? My stupid trash can analogy. But does everyone get that? And how variables are? Affirmative. Anybody not get it? If you don't get it from this, I don't know what else I can do as far as like a lesson or like an object lesson. Okay. So, with our trash can named sum, what we want to do is take the value outside of sum, or we want to take the value of sum, add something to it, and put it back inside sum. The problem with the way I just said that is that the order is not at all like, or the order of what I just said is not at all like what you actually type. So, the way that you do that is with assignment. First, I refer to the memory address that I want to change, which is sum. Everybody back on your code. Everyone back on your code. So I refer to sum. That's the trash can. That's the box. That's the thing that I want to be referring to. Okay? So now that I'm referring to that trash can, that box, I'm going to say that I want the value that is stored inside of it, which is what the assignment operator does. I want the value inside of it to be equal to the value that's already inside of it plus something else. So how do I get the value that's already inside of it? I just say sum. That's the value that's already in it. Then I say plus. Now what am I adding to it? I, because I is the odd number. Semicolon. Some of you got this. Just a couple of you, but some of you got this. There is a shorthand for this. Now this code right here is fine. This will work. But there's a shorthand that can make this a little bit less confusing and easier to read. I can put plus equals instead of that, and it means the exact same thing. Sum plus equals I. And once you understand that plus equals means the same thing as what we had before, you'll start reading plus equals and your brain will automatically know exactly what that means, and you'll say plus equals and you'll just say, yep, I'm taking a value and adding it to the pile. So this is kind of like, I've already got one can in here. I actually have two cans in here. So I've already got one can in here. Plus equals I is like I'm taking the single can that was already there, and now I'm adding another can. Same principle. That one was a little sticky.
So, questions. Then why am I not getting all 28?
What's that? Notice that sum is created outside of the loop. It is created outside of the loop because if I made it in the loop, what would happen? What happens if I do for int blah blah blah, but right above the if statement is where I put sum? What happens?
It would just be declared.
Right, well it would get reset to 0 every time. So if I took this and did that, if I did this right here, and pay attention to this because this might trip you up in future. If I do this, every time the loop runs, I am issuing a command to take sum, or I'm redeclaring it even, and set it equal to 0. Which means every single time the loop ran, I would effectively be erasing sum and starting over, which is useless because we don't get the actual sum out. Also, you'll notice that I'm no longer able to print sum because sum only exists in the for loop right there. There are times when we're going to do something like this because the effect of being able to assign it to the same name to something different every time a loop runs, sometimes we don't want that, but there are times where we actually want to do that on purpose. And the thing we do on Tuesday when we get here is actually going to do that on purpose. We're going to erase what we had before and reassign to it. And I'll explain why then. But Before we leave, are there any questions at all before you leave? I know you can leave now. Are there any questions?
Well,